Hello, a very good afternoon to all of you. Am I audible? Please let me know in the chat box. Okay, thank you. Okay. So last day, sir has discussed some of the algorithms like situations, matrix, multiplications, and after that max-min finding using dynamic divide and conquer rule, right? So these are the two codes that was your last day's assignment. So today we are going to start about a new thing, that is greedy method. Okay, greedy method, where we are going to learn about two algorithm, that is graph traversal algorithm. Okay, so before implementing it, you need to first finding out that how to do that. Like quick shot, we have already discussed that how to do the quick shot, right? Because if you are having a array, then how we performed it without using code, then also we can perform a particular array that can be sorted using a different technique. So different techniques have some different rules. Similarly, here also in case of graph traversal algorithm, we are having two traversing algorithm. One is BFS, another one is DFS. So before implementing it in a form of code, let's understand how to do it. Okay, so yes, first is what is graph traversal. Graph traversal, if we understand in a deeper view, it is nothing but we need to visit all the vertices. So if I asked you that what is the definitions of graph, can you tell me that what is the representations of a graph? Please tell me, because we have already covered the graph theory in your discrete maths, if I am not wrong. So if I give a definitions like G, V, comma E, what E denotes, what V denotes? Please send me the answers in this chat box. If I give you a definitions like G in the bracket V, comma E, then what is the meaning of this particular statement? Tell me in this chat box. G in this bracket V, comma E, what did you mean? What B defines and what E defines? Tell me in this chat box. Vertex and edge, absolutely correct. So you can understand that when I am talking about a terms like graph, it consists of two things. One is vertex, another one is edge. Okay, vertex, another one is edge, right? So here same thing. So whenever we are traversing any kind of graph, it means that we need to visit all the vertices of a graph in some systematic order. Yes, we need to apply some of the systems over here, and two traversing algorithms are there. One is BFS, full form is breadth first search. Another one is DFS, that is depth first search. So what is the meaning of graph traversal? We need to visit all the vertices. Okay, now let's start with what is BFS. Now this breadth first search can be done for tree as well as for graph. What I said, this breadth first search or breadth first traversal technique can be done for the tree as well as for graph. But what is the difference over here? For tree, we don't have any kind of cycle. What I said? For tree, we don't have any kind of cycle concept. But for graph, it can have any kind of cycle. But the traversing technique more or less same. But yes, for graph, there can be of any kind of cycle. But for tree, there is no possibility to have any kind of cycle. Right? This is the difference between breadth first search for a graph, breadth first search for a tree. Now here, suppose we are having a graph. Now our motto is to visit all the vertices. Our motto is to visit all the vertices. Now, how can I understand whether I visit a particular edge or not, or particular node or not? How? For that, we are using one array. This array actually defines how many nodes are present over here. And after that, after visiting one node, we are putting some status of that particular node. What I said? Just suppose we are having one graph, and a graph consists of nodes and edge, all of us know it. Now our motto is to visit all the vertices. Now it can happen that we are visiting a vertices more than one time, but which is not needed over here, right? For that we are using one boolean array, which actually used for checking whether I have already visited that particular node or not. If yes, then I don't take that node for my second traversing. If no, then only I will take it. This is the purpose of taking one boolean visited array. And the fourth point is that for simplicity, we are assuming that every vertex is reachable from the starting vertex. Obviously, that every edge, every graph should have some point that from that place you need to start your traversing. Suppose you are having one tree. So what is the starting point for traversing your tree? That is your root node. Similarly, for the graph as well, you are having one vertex which actually used for starting node, and we are assuming here that from the starting vertex we can visit all the vertex. Okay, from the starting node we can visit all the nodes. So this is all about your breadth first search. Now let's take a simple example. See, in this example we are considering a graph. Okay, now check, as I called you that here one cycle is present. As I told you that it is a possibility, your graph can contain any kind of cycle. So here we are having 4 nodes. What are they? 2, 0, 1 and 3. Now here I am defining 2 as my starting index. Now my next job is I need to check 2, and after that I need to check what are the vertex, what are the nodes which are adjacent to 2. What I said? Here I will check what are the vertex nodes which are actually adjacent to my starting node. If I have started with a node 2, then my next job is to check what are the adjacent to my starting node, which is 2. So if I am taking 2 as my start node, from this place we can understand my adjacent vertex are 0 and 3. 0 and 3. Now how I understand? See, this is a directed graph. Again, a graph can be of 2 types. One is directed, another one is undirected. If no direction is there, then we can conclude that 1 is also adjacent to 2. But as the direction is provided over here, so I will only check the outgoing edges. I will only check the outgoing edges. Okay. So here outgoing edges from 2 are, one is 3, another one is 0. Okay. This 2 is from 1 to 2, this is my incoming edge. So here we are considering only outgoing edges for checking that which one are the adjacent to 2. So here 2 nodes are there which are adjacent to 2. What are they? One is 3, another one is 0. Now once I get 3 and 0, so from this place I told you that I have already visited node 2. When I check my next node, that is 0, because 0 I get from my adjacent node from 2. So when I visit to node 0, again 1 and 2 is adjacent to 0. Again 1 and 2 is adjacent to 0. But here we will not take 2 for the second time, because I have already visited 2 at the initial stage. That is the reason why here we need to take one array, that is Boolean adjacent list, which is actually depicts once you have already visited that particular node, please change their status that it is already visited. If it is not visited, then only I will take. So once I checked the adjacent vertices from 2, I got 0 and 3. These are 2 outgoing edges that are coming from 2. So I will take 0 and 3. After that, when I take my second at the node which is 0, from where I found I am having two adjacent nodes. What are they? One is 2, another one is 1. But here when it comes from 0 to 2, I saw 2 is already visited. 2 is already visited. So I will not take it. So this is the point, that not to terminate your or not to become your process a non-terminating. That is the reason why we should take that Boolean adjacency matrix. Okay. So this is a simple examples where we can say yes, 2031, this is nothing but my adjacent vertices of this particular graph. Now let's understand in a deeper way. So again, this is the examples of a graph. So everyone please draw it in your copy. Everyone please draw it in your copy, otherwise you will not be able to understand. So this is a graph where we can say that I am having 6 nodes. 1, 2, 3, 4, 5, 6. Okay. Now so this is my graph where I am having 6 nodes, 1, 2, 3, 4, 5, 6, and from this graph we can understand that yes, it is a undirected graph. So previous one was my directed graph, but here it is nothing but your undirected graph, and we are considering 1 is my starting node. We are considering 1 is my starting node. So in BFS, one kind of data structure is used which is named as queue. In BFS, one kind of data structure is used which is named as queue, and we know queue follows nothing but first in first out methodology. Queue follows first in first out methodology. So please write it down, 2 things. One is BFS used queue data structure, and queue means first in first out. Queue means first in first out. So yes, this is my graph which have 6 nodes, 1, 2, 3, 4, 5, 6, and yes, it is a undirected graph. Now, as I told you that I need to take one adjacent matrix list for what? For taking their status. Now currently I am not visiting any nodes. So that is the reason why I put every node status as 0. What I said? Currently I am not putting any nodes, I am not visiting any nodes. So that is the reason why I am putting 0 in each and every nodes. That is 0 for 1, 0 for 2, 0 for 3, 0 for 4, 0 for 5, 0 for 6. Now why I have taken this kind of array? Because it's actually used for changing your status, that once you have visited, change your status at that time immediately. Okay. So this is the first time that if I am not visiting my nodes, this is the internal structures of it, that yes, visited nodes having all the 0 value for all the nodes, and I am having nothing to put in my queue. In the next slide, I am considering 1 is currently visited by me. Now I visit 1. So I am considering 1 is my starting node. So I visited 1. See, when I visit 1, immediately I change the status over here from 0 to 1. When I visit 1, immediately I change the status from 0 to 1, because initially the status was 0. Once I visited, I mark the next color, that is, if it is not visited, it was like in a blue. If it is visited, it was like a yellow. So once it visits, then I am changing the status from 0 to 1. But the remaining things are 0. Now once you visit, put that value in your queue. So queue currently contains 1. Initially queue was empty. Initially in this place queue was empty. Here queue was empty. But in the next state, when I visit my node, then queue contains my start vertex, which is 1. Okay. Now next thing is that once you got your start vertex, then how can we reach to get to my adjacent vertex from my start vertex? For that I need to dequeue my value. So here I am enqueuing my value. Next I need to dequeue the value. Next I need to do dequeue for checking the adjacent 2 nodes from 1. So in the next step, I am dequeuing my value. So I am again putting the empty status for queue and Q is currently empty and I am printing the value of 1. That means first visit the node, then again dequeue the value, then print the value. After that, once I print the value, once after dequeue process is over and after printing the first value, next I'll check what value is dequeued. 1 is dequeued. So I'll check the adjacent nodes from that dequeued node. So what is dequeued right now? Dequeued is nothing but 1. Now my next job is to finding out what are the adjacent nodes from 1. So from this place I get my adjacent nodes are 2 and 3. So in the next step, see, I am visiting node 2 and node 3. So I am entering this 2 and 3 in my queue because I have already visited. Node 2 and 3 because they are adjacent to 1. And yes, my printing status is same because once you are not going to dequeue, then you can't put it in the printf functions. So that is the reason why currently my queue holds the value 2 and 3 because these are my two adjacent nodes from 1 and the remainings are 0. Okay. So 2 and 3, these are my adjacent nodes from 1. So I changed the status of 2 and 3. Okay. Now next is, as I told you, queue follows first in first out, FIFO strategy. So first in first out means in between these two value, then first value inserted as 2, next value is 3. So if I apply FIFO, so next my value that is going to out nothing but 2 because 2 is entered first, 3 is entered last. So right now when I am doing the popping operations, so obviously 2 will be popped from the queue. Okay. So in the next step, check, I am popping 2 from the queue and printing it, and after that I am going to check what are the adjacent vertices from 2. So we will only enter those adjacent vertices once you dequeued that node. So as I dequeued node 2, so next I'll check what are the adjacent vertices from 2. What are they? One is 4, another one is 5. Now 1 is also adjacent to 2, but yes, I will not take 1. Why? Because 1 is already visited. So that is the reason why you need to check this status. From this status you can able to understand that which node is already visited and not. Otherwise it will going in a for loops and a long time. An infinite loop will occur if you are going to take this one again. So that is the reason why we need to take one adjacency list from which status. From that status we can get to know which node is visited, which nodes are not visited. So when I am dequeuing the value 2, then I'll put this value in printf functions and I'll check the adjacent for 2. What are they? One is 4, another one is 5. Yes, 1 is also there, but I'll not take it because the status is 1 over here. So I'll put 4 and 5 in this place and change the status from 0 to 1 because I have already visited. Change the colors reflections as well. Okay. Now next is Q means FIFO strategy. So here what is the first element that I need to drop? That is 3 because Q used FIFO strategy. So when I remove 3, so I print the value which is 3 and I'll check what are the adjacent to 3. So once you print the value 3, then you will check what are the adjacent to 3. Now adjacent vertices are nothing but 1, another one is 5. Check, 1 is already visited, 5 is already visited. So I don't need to do anything for the vertex 3 or I don't need to put any extra vertex in this queue right now because these two vertex are already visited. So I am not doing anything for this particular step. So next step is I need to again dequeue 4 because first in first out. So from 4 check what are the adjacent vertices. From 4 we are having 3 adjacent vertices. One is 2, another one is 5, another one is 6. Right? Now 2 and 5 is already visited because the status was 1. Now I am having currently 6. So I updated the status which is 6. Okay, 0 to 1. Okay, now after that these steps will continue until my queue is not empty. Until my queue is not empty. So again the same process will actually happen again. I need to dequeue the value of 5. Dequeue the value of 5. Then I'll check the adjacent vertices for 5. What are they? One is 3, 2, 4, 6, and both the vertex are already visited. Both the vertex are already visited. That is the reason why I don't need to do anything for these steps, because all the vertices are already 1. Hello, tell me, is there any doubt, students? Check whether I am audible or not. Today there is a huge problem of the internet connections. Students, please let me know whether I am audible or not, because the net connection is very poor over here. Please let me know once. Please let me know in the chat box once. Okay, so then just tell me that how much you have just understand. How much you just you clearly I'm clearly audible. How much time? Yeah, I am audible right now. It is perfectly okay. But is there any problem based on my previous all those slides, whatever I have discussed, whatever example I gave given to you based on BFS, was it okay? Was it okay? Please let me know once. Ma'am, when you are teaching from 4, 2 nodes are connecting. Okay, I am just explaining it quickly. You are audible, ma'am, all the time, but just slides were not changing. It actually happens for all the slides. Slides were not changing when you were explaining. Okay, right now just check. I am quickly explain all the slides once. Check it. So I am repeating it from the beginning, just check, because if you are not understanding this, then you can't be able to implement it in your code, okay, because all the things, all the pseudo code is actually applied over here through this example. Okay, so I am explaining it again, so please check it once. So this is the example of a graph where I need to perform BFS, okay. So from this status you can understand that 4 nodes are there, 1, 2, 3, 4, 5, 6. So as I told you that visited one is nothing but your matrix, which array which is actually take for to see the reflections, changing reflections of each and every node. So initially it was set as 0, okay, initially it was set as 0 because I have not visited any nodes till now, okay. And I am taking one data structure which is named as Q. So Q follows FIFO policy. FIFO means first in first out, okay. So these two things you need to understand. Here Q is actually used and it actually allows you for using FIFO data structure, FIFO policy, first in first out. So next I am visiting node 1. Next I am visiting node 1, then which means I am changing my status from 0 to 1. So once I visited a node 1, changing the status from 0 to 1 and immediately put the value in Q. Put the value in Q. Once you visit the node, put the value in Q. So this is the next step. Now my third step is that once you visit node 1, once NQ is done, then you need to immediately perform the DQ operation. Now once I perform DQ, then I immediately print the value of DQ'd. DQ'd value is now 1. Now next I will check what are the adjacent values or adjacent nodes from node 1. What are they? One is 2, another one is 3. So next step check. Next step, in the next slide, I am visiting node 2 and 3 because I have already DQ'd. Because I have already DQ'd the node 1 and I got my 2 adjacent nodes that are 2 and 3. Okay. Now my next step is to DQ2. DQ2. Why? Because it apply first, it actually used first in first out policy. That is the reason I immediately need to DQ the first element which is 2. So in the next step, once I DQ'd value 2, so it will immediately come in the print functions and after that I will check the adjacent value or adjacent nodes from 2. What are they? One is 5, another one is 4. So I change the status for 5 and 4 and 5 from 0 to 1. After that next value I need to DQ which is 3. So I DQ'd the value 3, put it in the printf functions and check the adjacent value from 3. Now check the adjacent value from 3 was 1 and 5. But 1 and 5 both the values or both the nodes are already visited. So I don't need to do anything right now. So after that next element to DQ'd, that is 4. So next element is 4. So I am DQing value 4 and check what are the adjacent nodes from 4. What are they? 2, 5 and 6. 2 and 5 was already visited. So I immediately put 6, change the status for 6 from 0 to 1. Okay. Now after that next my job is to DQ value 5. So once I DQ the value 5, I will check the adjacent value of 5. See, every values, every nodes are already visited. So I don't need to do anything. But still, why I am continuing my process? Because my agenda is to what? My agenda is to empty my queue. My agenda is to empty my queue. That is the reason why again I need to decode 6. Once I decode the value 6, I change the status from 0 to 1 and I decode the value 6. It will come automatically in the printf functions and check every values from 6 are already visited. So I don't need to do anything. So this is the final output which I got after performing BFS traversal for that particular graph. Like this way we need to perform or we need to make our algorithm. Okay, so these are the procedure. So just tell me whether it is alright or not. Is there any problem, students? Did you understand how it actually works? Did you understand, students? Okay, thank you. Now, next is the algorithm. Check whatever steps I am applying over here, same things I need to run or I need to use in my pseudocode. Check the pseudocode. So obviously mark S as visited. First step is that mark S as visited. What it means? S means nothing but my starting node. So that things actually we applied that starting node is visited. So I change the status from 0 to 1, which actually reflects that we have already visited my starting node. After that, next step is that add S to queue. Yes, we have also applied this step. Add S to queue means initially my queue was empty. Once I visit my starting node, then I put the starting node in my queue, right? Because I enqueued the starting node in my queue. After that, I am checking on conditions, that is while queue is not empty, so which it means that I'll perform the remaining steps if my condition is true. So that I actually told you na, that you need to dequeue each and every value until you need to continue each and every value until your queue is. So after that I am checking my condition whether my queue is empty or not, and my condition is true. My queue is not empty because starting value is already there. Now then I am taking one variable which is named as current vertex. So current vertex, I am setting my current vertex which is q.dequeue. So whatever value you are putting, dequeue that value, put that value in the current vertex. So that I did. After dequeuing the value, I am using one print functions where I put that value. So that things actually happens over here. So once dequeuing the value, that value should be put in the current vertex. Now after putting it, next I will check for each adjacent vertex is unvisited. That means I will check for the current vertex. That means if my current vertex is 1, then I will check the adjacent vertex from that 1. So whatever adjacent vertex are present, if they are not visited, then I will do the rest of the steps. What are the steps? Add adjacent vertex to the queue and mark adjacent vertex as visited. So these the things are actually demonstrated in your example. That is the reason I told you please do it in your copy, because every steps are actually demonstrated in this example. Whatever steps I just told you. So first initially I put S is visited. S is nothing but your starting vertex, starting node. After that I am putting S to my queue. Yes. Next I am checking my queue is empty or not. Yes, the queue is not empty because currently queue holds your starting vertex which is S. If the queue is not empty, if my condition is true, then only I will go for the next steps. What are the steps? After putting the queue value, then I need to dequeue the value immediately. That steps I applied. After putting 1 into the queue, in the next step I am dequeuing the value and put 1 in the printf function. So current vertex is nothing but your 1 in that case. Then I will check what are the adjacent vertex from that current vertex. If the adjacent vertex are not visited, then we will put it in the queue and that adjacent vertex marked to be as visited. So this is the pseudocode, or we can say it is a rough pseudocode for applying any kind of BFS traversing algorithm. Okay? Okay? Now, here we are having some problem because we are exploring each and every nodes blindly. We are exploring each and every nodes blindly. That is the reason why we need to modify our pseudocode. We need to modify our pseudocode and we need to put some of the informations in our pseudocode. We need to put some of the informations for each and every graph in your pseudocode. Okay, so that is the reason why I need to modify my pseudocode. So we can say it is, or we can consider that it is my rough pseudocode, because here we are exploring each and every node blindly. That is the reason why I need to change my pseudocode and I need to modify it. Okay, for modifying my pseudocode, I am taking another extra array. One is level, another one is parent array. One is level array, another one is parent array. Now level array is actually tell you that a particular node is how far from your start index. See, in this example, I am having one graph where 1, 2, 3, 4, these are my 4 nodes. From these definitions I can understand that the distance between 1 to 2 is 1, because this is only first child of my parent node. But when I am taking the nodes like 3 and 4, for both the cases they are my of distance 2, because this is my distance 1, this is my distance 2. So the distance between 1 to 3 is 4, the distance between 1 to 4 is 2, the distance between 1 to 2 is 1. So this actually defines, for defining these things I need to take one level array. Another one is parent array. Parent array means it actually tells you via which vertex you are reaching to a given vertex through BFS. So these two things I need to add in my pseudocode, because in my previous pseudocode we are not getting anything, any informations about the graph. We are just blindly exploring it, but which is not needed over here. That is the reason why we are taking 2 extra array. What are they? One is level array, another one is parent array. Level array defines you that how far a particular node is from your parent node. So 3 and 4 is of distance 2 from 1. Another one is parent array, means it actually tells you via which vertex you are reaching to a given vertex in BFS technique. So these 2 array you need to incorporate. So this is your final pseudocode. Check, where I am creating one function named as BFS, and after that adjacent list means yes, it is a boolean array. After that S is nothing but your starting vertex, then level and parent. These 2 array we are taking. And initially all the level vertices and parent vertices I set as -1. What I said? These things, that see, parent and level, all the vertices values are nothing but my -1. This is my initial steps. Okay. And after that I am putting level S as 0. Level S as 0 means yes, I am changing my first value level S, starting index value to -1 to 0. Then I am adding this S to Q, and after that I am checking some of the conditions which is more or less same with your previous pseudocode. What are they? If Q, while Q is not empty, then I will perform some of the thing, that is current vertex equal to Q into DQ, and after that we are performing one for loop to check how many adjacent vertices are present for that current vertex. Then I am checking if the level of adjacent vertex is -1, then I will add it to the queue and I will change some of the status of the level and parent node. So let's take to understand this example using a example. Check it. So initially my status was -1 for level array as well as parent array. All the values are -1. Okay. Now next step, I told you that level S equals to 0. This is again our initial step. So level S equals to 0 means I am considering 1 is my starting vertex and S1 is changed from -1 to 0. This actually happens over here. So I have changed the level of S, that means starting node, from -1 to 0, and the remaining things are same. And the remaining things are more or less same. Okay. Now after that, only one iterations I incorporated. I'll explain over here. Check. So after changing the status of it, I am putting that particular node in my queue. So queue currently hold 1. This one is nothing but your node 1, because you are changing the value from -1 to 0 and you are inserting this value to your queue, which is change the status from -1 to 0 and entering the node to queue. Okay. After that I am checking my conditions. While Q is not empty, now my condition is true. How? Because Q currently hold 1, having 1 node, right? So the condition is true. If the condition is true, I am putting my current vertex, which is 1. So whatever value Q hold, that I am storing in my current vertex. So currently current vertex holds 1. Then I am immediately performing DQ. So I am performing DQ means, so Q currently hold null thing. So initially it was 1. After performing DQ operation, Q is currently hold nothing. After that I am checking the adjacent vertex from the current vertex. So as my current vertex is 1, so I will check the each adjacent vertex from the vertex 1. What are the adjacent vertex from vertex 1? Check, only 2 is adjacent to vertex 1. Only 2 is adjacent to vertex 1. So here, that is the reason I put for each adjacent vertex for vertex 1 to vertex 2, I will put if level of adjacent vertex equal to -1, I need to check it. Level of adjacent vertex is nothing but level of 2 is equal to -1. Check. Level of 2 means 1, 2. 1, 2, 3, 4. Level of 2 is -1. Level of 2 is -1. Now -1 equal to -1. The condition is true. If the condition is true, then I'll add this adjacent vertex to Q. So what is adjacent vertex? Vertex is 2. So Q currently hold 2. Now next is I am changing the status, that is level of adjacent vertex equal to level of adjacent vertex plus 1. So if I perform, I put the value like this, that is level of 2 equal to level of 1 plus 1, which is 0 plus 1, which is 1. And finally parent adjacent vertex equal to current vertex and parent of 2 is equals to 1. Okay, so like this way it will change your final status. So once I perform these steps, I'll get the output, which is, see, after performing the first operations, I'll get the level and parent array. Here I change the status of level and parent array after performing 1 iterations. After performing 1 iterations. This will continue until my Q is not empty. So from these steps we can understand, that how far your node is from your parent node. So here after performing each and every iterations, finally I will get the level and parent for each and every node as 0, 1, 2, 2 and 0, 1, 2, 2. This is the final output after doing each and every iterations. So level actually defines how far your particular node is from the parent node. So this 0 is nothing but your starting node 1, this one is nothing but next node 1, 2, then 3, 4. So the value of each node is coming like 0, 1, 2, 2. So check it from your graph. Check, 3 is nothing but of distance 2, 4 is nothing but of distance 2. So I get the answers 2, 2, which is matched, and I am having next value as 1. So check it, yes, the distance from 1 to 2 is 1, again it actually matched. So like this way I can have the informations of each and every node. Right? Initially we don't have any informations for each and every node, but currently I am having the informations of each and every nodes. That is the reason we need to add 2 array. One is level array, another one is parent array. Now here this code is actually runs. Here the for loops, while loop is actually runs for each vertex. So for each vertex, if you are having v number of vertex, so the overall complexity will be nothing but big O of v, and this for loop will run for each edges. If you are having the edges like e, it will run up to order of e. So if we combine both the things, I'll get my overall complexity as big O of v plus e, where v is nothing but number of vertices, e is nothing but number of edges in your graph. That's all from my end. Like this way I am completed my BFS. So you are having your next link where Panchali ma'am will discuss about DFS technique. Before ending my session, do you have any doubts to understand? I'll share this PPT in your group as well. Do you have any doubts? What is the relationship between level and parent here? Yes, level and parent means level actually defines you that how far a particular node is from your parent node, because if you are having a large tree, then you can be able to explain that if your leaf nodes are there, and if someone asks you that how much distance actually leaf node covers from the parent node, from that place you can be able to understand that yes, it is a distance of 4, distance of 3, like this way. And parent node is static but actually defines you if you are reaching up vertex 1 to vertex 2, okay, vertex 1 to vertex 2, by using which node you are actually going. So suppose you are reaching vertex 2 for the first time via vertex 1. Suppose you are reaching vertex 2 via vertex 1, then here the parent of vertex 2 is nothing but your vertex 1. What I said, you are reaching vertex 2 via vertex 1 for the first time, then the parent of vertex 2 would be vertex 1. So here parent node is actually defined, so via which node you are actually reaching to your solutions. Okay. That's all about level and parents node. Do you have any doubts? Please let me know here. Otherwise join your next session that is already defined, that is already in your Telegram group. The link is already there. If you are not having doubts, then please. What is that -1? Yeah, -1 is in the previous example I told you na that it was like 0. It was set as 0, that if the nodes is not visited, any nodes is not visited, then I'll set the values like 0. But here I am taking the default value which is -1. -1 defines that I am not visiting any nodes right now. Okay, I am not visiting any nodes right now. That is the reason I am putting -1. You can also put 0 on that place. It doesn't make any sense over here. You can put it as it's a default value. You can take any kind of default value on that place. Okay, because we are changing the status. Whatever value you are getting, that need to be changed to 1. Okay. Okay, Shubhadev. Do you have any doubts, students? Do you have any questions? Please ask me here. Okay, ma'am, got it. Okay, then join your next session. Join your next session, which it was already there in our Telegram group. Check the link and join there immediately. Okay.